Could you please explain only these three facts?
Okay, so for fact one, they're trying to say that any number, any positive integer, you can write as a
Okay, okay,
multiplication
let's
of.
do this way. Let's do this way. Can you take any other example than 1500? Can you show it in the screen if possible? Can you try?
Okay.
Yeah. Okay. 2 power 4, 5 power 2. Right. You can do the prime factorization also on the screen. Otherwise, I'll write it. I'll write the prime factorization part. You took 2000. You said, okay, you're doing it. Okay. Five, five. Five. Okay. All right. So it is 2 raised to the power 4 times 5 raised to the power 3. Okay. Is there any other way of writing this 2000 as a product of a prime numbers?
No.
No. You can't use 3. You can't use. Okay, you have already used 5. 7 is also not possible. 11 is also not possible. 13. Yeah. Yes, there is no possible way of writing 2000 as a product of prime numbers. All right. Okay. So fact 1 is clear from this. How would you explain fact 2?
So if you have n and like let's say d is a factor of n, so d would have to be a multiple of whatever n is a multiple of.
Factor of 2000. Yeah.
Yeah, so let's say 2000 is n, and then d is 50. And so 50 can only be, it can't be a multiple of 7. It can't be a multiple of anything 2000 is not a multiple of.
And also, you should state you cannot divide the 2 power 4 by 2 power 5.
Yeah.
Similarly, 5 power 3 by 5 power 4 or 5 power 5, anything which is greater than 5 power 3, right? So in the fact 3, oh yeah, that is actually fact 3. Okay, okay, yeah. All right. So we have discussed these 3 facts. From these facts, we can say the positive divisors of capital N is equal to P1 per A1, P2 per A2, and so on. Pk per Ak are the integers of the form. And D is equal to P1 per B1, P2 per B2, and so on. Pk per Bk.
Yeah.
For example, if you consider 500 as, 1500 as capital N, P1 power A1, P2 per A2, P3 per A3 is 2 raised to the power 2, 3 raised to the power 1, and 5 raised to the power 3. Here, A1 is 2, A2 is 1, and A3 is 5. So P1 is 2, P2 is 3, and P3 is 1 minute. Did I confuse? Okay. Actually, A1, A2, A3 are power right. Okay. So it's supposed to be 2, 1, and 3. P1, P2, P3 are the bases. So they are 2, 3, 5 respectively. All right. So this is for N. For the devices, they are saying P1 per B1, P2 per B2, P3 per B3, and so on up to Pk per P2. Right. And we knew the rule. We knew the rule that the factors of the devices cannot be greater than the power of this P1, P2, P3, which means this B1 should be lesser than or equal to A1, right? And it is also a positive integer. So we should include this 0 greater than or equal to also. Do you understand this fact? We already learned this. You can only divide 2 per 2 by 2 per 2. You cannot use 2 per 2 by 2 per 3. This is not possible. Do you understand this part?
Oh, sorry, my mic was muted. Yes.
Do you understand?
Yeah, I understand.
So if you apply the same boundaries for the rest, B2 should be lesser than or equal to A2, and of course it is a positive integer. Similarly, B3 is supposed to be lesser than or equal to A3, and it is also greater than or equal to 0. Okay. Which means, okay, which means there are A1 plus 1 possible values for B1. Do you understand why do you have A1 plus 1?
Yeah, because it can also be 0.
Because it can also be 0. Yes. And for B2, A2 plus 1. And for B3, it's A3 plus 1. So it goes on like that. So these are the possible values. Since n has prime factorization, 2 power r, 5 power, is that 8 or is 1 minute?
Yeah, I think it's 8.
I think it is yes, I guess. 1 minute. It is yes. Like 1 minute, 1 minute. I'll just zoom it. Yeah, it's yes.
It's
It's
S.
yes. It's just you'll be substituting some random integer on R and S.
Yeah.
It's like 2 power 1, 2 power 2, 5 power 2, 5 power 3. So you take any number, whether it is 1500 or 2000. Here it is given as 20,000, right? So if you consider that, you can express that as 2 raised to the power some power. I have assumed the power value was the variable R here. And 5 power, yes. P3 power A3, P4 power A4, and so on. Pk power AK for some distinct prime numbers. P3, P4, and so on, Pk, none of which equal to 2 or 5. For some positive integers, A3, A4, AK, and some non-negative. Non-negative integers means it's just positive. And also 0, R, and S. So let's go back to the question and check. So in the question, it is written that this 20,000 have the properties that 2n has 64 positive devices, including 1 and 2n. 5n has 60 positive devices, including 1 and 5n. So you are elaborating in this way. For 2n, you are writing 2 power r plus 1 because you will include 0 also in this. So you will be having r plus 1 factors. So it's 2 power r plus 1 and 5 power s. P3, A3, P4, A4, PK, AK. You are just writing the same general form for this. For 5 power n, for 5 power n, you are including the factor. So it is going to be 5 power s plus 1. And you are just writing the remaining thing as it is. And in a question, they already said it has 64 positive devices. So you are equating this to 64 and then 5n to 60. You are equating the 2n to 64 and 5n to 60. So here they are just comparing the powers. Okay. So they have just increased its value by 1. You can see it. You have r plus 1 here. It is written as r plus 1 plus 1. You have s here. It's s plus 1. A3 is A3 plus 1. A4 is A4 plus 1. And AK is AK plus 1. Do you understand?
Yeah.
So you are applying the same condition for the second one too. So it's R plus 1, S plus 1 already. So it increased to S plus 2. A3 plus 1, A4 plus 1, AK plus 1 is equal to 60, which is given in the question. So finding the positive common divisor of 64 and 60 is pretty much easy because we are already new. We are already aware of this. Positive divisors of 64 are 1, 2, 4, 8, 16, 32, and 64. Right? We know this. And of this, if you try to find the common divisors, for 60 you will have only 1, 2, and 4. 8 cannot divide 60, 16 cannot divide 60, 32 cannot divide 60, 64 cannot divide 60. Do you understand this part?
Yeah.
First you have to list down the factors of 64 and factors of 60, and then you find the common common factors. Okay. So you will have like 1, 2, 4, 8, 16, 32, 64. And for 60, you will have like 60, 30, 15. What else? We'll have 1, 2, 4 also will have. We'll have 5, 2. We'll have 6 as well. There is no 7, 8, 9, 10. Yeah, you will have 10 as well. This is 15, 15, 12 also. Yeah. So you will list down all of them and then you will just circle the common one. Okay. So that is how you will find the common divisors of 64 and 60. So let's discuss this case by case. Here you have A3 plus 1, A4 plus 1, AK plus 1. We are segregating this part into two. Okay. So let's assume this is one of the common divisors of 64 and 60. So they are assuming this A3 plus 1, A4 plus 1 and AK plus 1 as 4. So if you assume that part as 4, you will just replace, you will just have to replace this by 4 and this part also by 4. Here they are in multiplication. So just move it to the right side, it becomes division. This is very simple. So once you substitute 4 and move it to the right side, it becomes 64 by 4, which will give you 16. So if you apply the same strategy for the condition 2, it's 60 by 4, which will give you 15. Is this part clear?
Yeah.
All right. So over here, it's just a simplification. You are just expanding this. So this is, it's just RS, R, 2S, and 2. RS, 2R, 1S, and 2. Okay, this is very simple. Can you simplify this part? Can you simplify this using the elimination method, the one which you studied in the algebra? Can you find the value of R and S from these two equations?
Okay.
Did you get the answer?
Almost.
You got it?
Um,
Are you equating them?
yeah.
Why?
Huh?
The first one is 16 and the second one is 15. Why would you equate?
I added 1 to the 15 one.
Okay, you can do subtraction or addition. You try to do subtraction. You subtract both the equations. You'll be able to eliminate something.
Oh, okay.
That is what elimination method, right? Okay. Yeah. So the value of R is 2. The value of S is 3. Good. Good. I gave you stars. Very good. So it's 2 and 3. So if you substitute the value of S and R, uh, the given equation, you will substitute here, okay? You will substitute the value of R and S over these two equations. If you do that, you will have 2 raised to the power 2, 5 power 3, P3, P4. And we knew that P3, P4 is not equal to 2 or 5, and N is equal to 2 raised to the power 2, 5 power 3, and P3 power 3 for some prime P3 are not equal to 2 or 5. We can verify that 2n and 5n have the correct number of positive divisors in each case. See, we do have three things, 1, 2, and 4. So we have to verify all these three cases, okay? So first we are done with the 4. So now you have to assume the case as 2. And you have to solve for 1 also. You have to assume that is case 3.
Yeah.
So for equal to 2, very simple. You just have to substitute this as 2. If you take it to the right side, it will divide 64. So 64 divided by 2 will give you 32. So do the same for the second equation. 60 by 2 will give you 30. So you'll be ended up having this one. And I'll show you the table how to do it. Okay. So if you substitute the case 3 as 1, so again you will take that A3 plus 1, A4 plus 1, A5 plus 1 part as 1. And if you take it to the right side and divide it, still 64 by 1 going to be 64, and 60 divided by 1 is 60. So that is how you got this case. Okay. But still we need to simplify this. We need to find their possibilities from the equation. So from the case 2, you have R plus 2 S plus 1 is equal to 32. R plus 1 S plus 2 equal to 30. So
Yeah.
we can divide them into a table, like we can row into a table. R plus 2, S plus 1, taking the first condition. Okay. So R plus 2 can be expanded as R and R plus 1. And for S plus 1, you can also write S and S plus 2, because here also you do have S plus 2 and R plus 1. So you're just kind of including all the terms here. So because you're just going to find all the possibilities, okay? Which is why you are writing all of them.